Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 20th, 2025, about 4 weeks ago. The standout claim is that a 32 billion parameter open source agent sets new state-of-the-art on medical deep research benchmarks while staying competitive on general tasks. The paper is titled MedResearcher-R1, Expert-Level Medical Deep Researcher via a Knowledge-Informed Trajectory Synthesis Framework. And the implications for model training are quite significant. In short, the work combines knowledge graph-based data synthesis with specialized medical retrieval and a two-stage supervised plus reinforcement learning pipeline. On Hugging Face, you'll find MedResearcher-R1 with 32 billion parameters, safe tensor weights, quantized variance, plus example inference and evaluation scripts from their GitHub to reproduce results. Alright, Figure 1 shows that the specialized agent leads on medical research while staying strong on general tasks. The left panel highlights MedBrowse-Comp, where the blue bar tops rivals, which signals better multi-hop medical reasoning. The center panel reports GAIA with nearly the same score as the strongest general agent, so generalization holds. The right panel covers Xbench Deep Search, again with a narrow edge. Together the bars indicate consistent gains rather than a one-off spike. So Figure 2 contrasts a generic research workflow with a medical-first workflow that actually reaches a correct answer. The example centers on identifying valsartan, which is a blood pressure drug, and the figure shows that the winning path adds medical tools and a verify step before concluding. The top row fails because it searches broadly and answers without checking authoritative sources. The bottom row succeeds since it routes through medical databases, then verifies mechanism and safety evidence, so the final answer is trustworthy. So Figure 3 explains how the dataset forces genuine multi-hop reasoning by turning rare medical entity graphs into long-chained questions. The figure shows an end-to-end pipeline, which starts from PubMed entities, screens for rare ones, then builds a knowledge graph and samples the longest path. Longest path means the route through the graph with the most valid steps, so the question demands several tool calls to connect evidence. The right panel gives an abridged question and stepwise reasoning that traces that path to a single answer. Alright, Table 1 reports head-to-head accuracy on MedBrowse-Comp, which measures how many clinical questions each agent answers correctly with one try. The table shows the 32 billion parameter system, leading with 27.5, so it surpasses O3 Deep Research and a search-only setup. That margin matters because MedBrowse-Comp requires multi-step retrieval and verification, not just text prediction. The comparison implies that specialized medical tools and training improved reliability on hard cases. Wrapping up, 2 takeaways stand out: targeted data synthesis using rare entity knowledge graphs, and a medical-first tool suite drive reliable multi-hop reasoning, which lifts accuracy on tough clinical queries. The broader implication is clear. Smaller open models can surpass larger systems when grounded in domain knowledge and iterative verification. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.